SOHO serves two purposes. One is to probe the physics and structure of the sun. The other is to watch for signs of danger. How might the next huge solar blast play out? While we go about our lives unaware, a searing blast of particles could erupt off the sun into space.
Hey, Barb?
Yeah?
The first to see the event would be researchers at SOHO Mission Control.
It's a big one.
Yeah, it's a full 360-degree eruption. There's no doubt about that. Yeah.
SOHO literally can't tell if the blast is coming or going, heading directly toward or away from Earth. Nearly 5 billion tons of solar matter races through space, dwarfing Mercury.
We got a pretty good chunk going to the south and some east and some west here. So let's go look at the EIT data.
Great.
And see.
All right.
What you got?
It's really a big event on the front side. There's a big flare here, which trigger lots of activities here, and I think you can see something moving out from the sun.
At a speed of 1 million miles an hour, it reaches Venus 2.5 days after leaving the sun. Big Bear's instruments detect a magnetic disruption on the sun's face.
Okay, Big Bear saw it as well.
The SOHO team still doesn't know if the blast is coming toward Earth. They must wait to see if the spacecraft itself is struck.
Any idea how fast it's going yet?
There it is. We got a CME coming at us.
Definitely Earth directed.
No uncertainty remains. The blast has hit SOHO and is on its way to Earth.
It's going to be less than an hour before it gets here. I should really call the polar team to tell them. So you think you should put out an alert? Thanks.
Only a 1-hour warning goes out to defense, satellite operators, airlines, those tapped into the system. But most people would be completely unaware of the solar hurricane bearing down upon them. A communications satellite is hit. Although its orbit doesn't change, it's suddenly left outside the Earth's magnetic field. Spinning in place, it loses its bearings. All contact is lost. Without its protective shield, the satellite is now exposed to a direct hit from the blast. Killer electrons bombard vulnerable circuit boards, building up a dangerous charge. The satellite is literally fried. But the greatest impact might be felt on Earth. A solar burst could silence radio communications, leaving the military open to attack. Planes flying at high latitudes might be bombarded with radiation, exposing passengers to the equivalent of 100 chest X-rays. Pilots could lose radio contact with air traffic control. And with thousands of planes in the air at one time, the results could be deadly. With weather satellites out of commission, hurricanes wouldn't be seen coming. Our busiest cities might suffer the worst effects of the solar storm. ATMs could crash, pagers go silent, long-distance phone calls become impossible. And perhaps the ultimate nightmare comes to pass. Your cell phone goes dead. Today, Today, we get only a 1-hour warning before a solar blast strikes Earth. Can we do better? An answer may lie in our own backyard.
Here, we have to fiddle with this box. We connect those two in there.
A boy playing with rockets may not be our solution to solar science, but not every kid has a rocket scientist for a mom.
5, 4, 3, 2, 1, 0, ignition!
Lika Guhatakorta is program scientist of one of NASA's most ambitious solar expeditions. Scheduled for launch in 2004, the Stereo mission will send twin spacecraft to view the sun from 2 different vantage points. It will take a 3D look at our star and help us measure the speed and direction of a CME.
Stereo, for the first time, will be sending 2 spacecraft that will veer away from the Sun-Earth line to get 2 different perspectives on the sun. And what that's going to give us is a stereoscopic 3-dimensional view of this stellar object for the very first time. And we'll see what truly are the shapes and sizes of these massive ejections that we see from the sun.
Among the space relics in a NASA museum, Lika and her son play out the future mission.
For instance, Tristan, my son, represents the sun of our solar system, and the balloon he is blowing is a coronal mass ejection pointed in the Earth direction. I represent one of the Stereo spacecraft, which is in the leading orbit, and this spacecraft is going to view the coronal mass ejection from this angle. Let's go to the second position. This is the second position of another Stereo spacecraft, and we are going to view the coronal mass ejections from this angle. Scientists are going to combine these 2 views and actually produce a 3-dimensional image of the coronal mass ejection coming towards Earth for the very first time. And it's going to allow us to determine the speed of the coronal mass ejection, its magnetic field geometry, and its composition.
A CME builds on the face of the sun. Stereo sees it's headed right for us.
3, 2, 1.
Traveling at over 1 million miles an hour, it aims for a head-on collision with Earth.
Tristan.
As this mom well knows, the sun can sometimes be naughty. The cold, dark vastness of space is warmed and illuminated by stars. Some may be better behaved than our sun, others more unruly. But our planet's fate is bound to our daytime star, for better or worse. We literally live inside the extended atmosphere of our sun. So we must continue to study its moods.
The sun is a star we live with, and in this technologically driven society, if we really don't understand the sun-earth connection, I think we are at a loss.
What we should be doing is to anticipate as much as we can potential effects. Then we should try to learn as much as we can about the sun during this solar maximum and the Earth-space environment so we can plan for the next one.
This solar maximum is really very exciting for us. We've got the most spectacular observatory in space that we've ever had. And we have lots of observatories on the ground. We're going to be able to look at it this time and see what's going on in much better ways than we've ever been able to before.
I don't think scientists really fully understand yet the true nature of the sun. It's one of those that the deeper you look, the more questions you come up with. And it's almost like this mystery. The deeper you probe, the more confusing and the more mysterious it becomes.
The sun will continue to nourish our planet, rising, setting, drenching our land in light and warmth. But our star, the only star whose face we see, is temperamental. We are beginning to discover its real nature. The Inuit have long known their lives were bound to the sun. They embrace and celebrate their connection to the heavens. Could they know something we have long forgotten or tried to deny? Our lives dance to the rhythm of the sun. As we continue to explore our ever-changing star, we may start to see it in its true light.